Dr. Edward Diei, who you have already seen on the screen, is the next person to address us. He is the managing partner in Lane Tech Solutions, LLC. Prior to his present position, he spent more than 21 years as engineer, quality manager, and other senior positions in top USA companies such as Rockwell, Alliant, General Electric. Dr. Diei will be speaking about engineering ecosystems and how they support engineering education and the creation of goods and services. Dr. Diei began his engineering training and initial working experience here in Nigeria, and he brings to the table both a local and a world view. Graduating first class in mechanical engineering at the University of Lagos in 1976, he proceeded to the prestigious University of California, Berkeley for his PhD in the same field. He also has an MBA from Chicago. It's a privilege and my great honor to invite Dr. Diei to share his thoughts with us on engineering training in Nigeria and the United States, lessons from two ecosystems. Dr. Diei, over to you. Thank you.
Quickly, my topic is engineering training in Nigeria and United States, lessons from two ecosystems. And as you can see here from the takeaway box, I'm going to give an overview and a challenge. Here are my objectives for today's conversation. I just want to discuss the major components of an ecosystem for training engineers. And then I will highlight some of what I consider to be the critical success factors. And then wrap up with improvement suggestions for Nigerian educators and students. So just by way of introduction, we all are familiar with the definition of an ecosystem, the biological community of interacting organisms and their physical environment. But in general use, it's really talking about a complex network or an interconnected system. And so I'm showing here a quick example of a food chain, just to get everyone level set and relaxed. As you can see here, we can think of this food chain as starting with the grasshopper eating the grass, and then perhaps the mouse will eat the grasshopper, the snake will eat the mouse, the hawk will eat the snake. I haven't actually seen a hawk eat a snake, but who knows? And then the hawk itself will die and get into the soil, and supply its nutrients to the soil. The sun and the water and the rain contribute, and the cycle starts all over again. So that's what it is. But realistically, what we are going to discuss today is what I call a learning ecosystem. And we have this nice and actually a very elegant description that I got from, as you can see here at the bottom, a blog by a fellow Ryan Udy of EJ4, which is kind of a training company. It's part of the HIS company system. So a learning ecosystem is a system of, and these are the key things: the people, the content, the technology, the culture, and the strategy existing both within and outside an organization. And then each of these things have a huge impact on both the formal as well as the informal learning that goes on in that organization. So with that said, let's take a look at what I propose to be an engineering ecosystem. As you can see here, my view is that we can think of this as two ecosystems. There's the ecosystem for training engineers and another ecosystem for professional engineers. And for the purposes of our conversation today, I'm only going to focus on the ecosystem for training engineers. So as we're all familiar with, this starts all the way from pre-college preparation. And here the idea is to expose kids and young adults to science and technology. Next comes the college coursework itself. Once you get admitted into college, we use the coursework to learn about engineering fundamentals. We combine that with our lab experiments to get this to see the theory in action. And then as all that is going on, a huge part of that is the funded research, because that's how we are able to collaborate with government and industry. And then in addition to that collaboration, the pre-graduation work experience is really huge, in my own opinion, because this is what allows you to boost your knowledge with practical experience. And we'll talk a little bit more about each of these blocks on the next slide. But then finally, you graduate and you get into the industry for your work experience. And this is your opportunity to now showcase your skills and advance your career. All of this, of course, then leads to the ecosystem for the professional engineers, which, like I said before, is outside the scope of today's conversation. Pre-college preparation. This is how we are able to prepare, young adults, like I said before, for college work. And here, what my own observation is that here in the United States, there is a lot of career guidance and also STEM outreach. As you all know, STEM is science, technology, engineering, and math. And these are all taking place at the high school level, at the community college level. And it allows exposure of these young people to what is possible, get them excited about science, about technology, and also it begins to separate people who are really talented in the arts area so that they can go that route, and people who are talented in science can follow their path towards engineering and things like that. Now, during my time when I was in high school, we really didn't have what I would call career guidance. All that happened was if you are good in math and physics, you went into engineering. If you are good in chemistry and biology, you went to medicine. And then if you are good in the arts, you go into law or political science and the other fields. But that was about the extent of it. But here in the United States, there's really a lot of focus on getting young people to understand what direction they want to do. And in fact, you can take a lot of advanced placement classes in high school and be able to get college credit for those. The other thing I want to mention here is that there is a great deal of collaboration between the two-year community colleges and the university systems. For example, here in Wisconsin, where I am, the University of Wisconsin system, all of the time allows many of these courses that people take at the college level, accept them as credit towards their university education. So that's a huge part of how you get young people prepared to go into college. Now, once you're in college, as we all know, coursework and instructors are the key success factors. And I believe that this is an area of strength for the Nigerian university system, because I can recall that during my time at UNILAG, we had great instructors, people like the late Professor Awojubi, Professor Diei, and others, really taught us great classes. We may not have had, state-of-the-art facilities, but we did have a great deal of lab equipment, thermofluids that allowed us to, really examine the theory and get our hands into how engineering systems actually work. So lab experiments is a huge part of the training. And, here is where I really get excited about the opportunity that you are now getting through this design contest, because you're going to get the opportunity to take your coursework, combine that with, your CAD design, your, computer-aided manufacturing, and, really showcase what you are, add a lot of your own creativity. I can remember a lot of experiments that I did, a lot of projects that I did in my time, and they really open my eyes to what is possible. So I encourage all of you to, think broadly. If you have opportunities to use something like, 3D printers to, create some models of your actual physical models of your product, I would greatly encourage that. But lab work is huge. So now let's talk about the funded research. As many of you know, in the United States, this is a big, big area. The government spends a lot of money supporting basic research, and the industry, spends a lot of time and effort, supporting applied research. Of course, this funded research is what actually allows the professors, it pays part of their salary. I actually consider this funded research to be the lifeblood of the big research institutions. I personally benefited from it. For example, when I was at University of California at Berkeley, my project work, which was in developing sensors and controls for manufacturing systems, really, we got funding from the National Science Foundation that allowed us to do a lot of that work. The part that funded research plays in university education, even at the undergrad level, what I'm showing you now is the website of the University of California at Berkeley. And what you are seeing here are the endowed chairs of the professors. Endowed chairs means that these are multi-year commitment of funds to support the work that is being done by these professors. This work gives the professors ample time and energy to continue to do their research and support the students that are working, that they are supervising their work, as well as it also contributes significantly to innovation and creativity within the undergrad level. And this is just a huge list of the kind of support that a university like that gets. And my hope is that one of these days I'll be able to go to the UNILAG website and see this type of endowed chairs and distinguished professorships, because that will be the signal that the Nigerian industry community, the Nigerian foundations, and the big guys who have money in Nigeria are truly making investments in the university system. So that's what's going on with funded research. But really, a huge part that I can't emphasize enough is the pre-graduation work experience, internships, apprenticeships, and summer jobs. This is how you get your feet wet. This is how you get yourself introduced into industry and really begin to understand what engineering is all about. So I highly recommend it to all of you. When I was in UNILAG, again, I had great experience, all 3 years of vacation job. My first year, I did vacation job at the auto service center for auto repair shop for the national radio station, and that was great experience. They taught us how to repair the horns for cars, and horns turned out to be using a little bit of electromagnet to act as the actuator for when you actually press the horn. So that was great experience after my first year. Second year, I worked for a detergent company that was making Omo detergent. And there again, I had great experience, even though it's a chemical company, which wasn't my area of focus. But as you can imagine, there were lots of pipes, lots of pumps in there. So this actually gave me a great opportunity to see pumps in real life and how they worked. And then my final vacation job was with, I think it was Thermocool that makes refrigerators. And there again, I had great experience. It showed me the entire refrigeration cycle, the compressor, the condenser, the expansion valve, the coil, all of that system in real life, how they work, how they put them together. So I had a great experience. I highly recommend those for you as you are doing your engineering training. And then, of course, finally, post-graduation work experience. This is driven principally by job availability and placement services. The way we know that industry is really supporting university education is a site like this for GE, where you can see that if you go to that site, they have a whole section here dedicated to students. And so if you click on that, you will see what is going on. And they talk about how they give opportunities to students and how that, exposes them quickly. And these are some of the internships and the co-ops that those students are able to do. if you look at the development programs, again, here you will see all sorts of rotational opportunities that they provide to this. Now I'm talking about the graduates. Once you graduate, and you can see this thing here, which I really like. Over 25% of today's top leaders at GE started on this program. These programs are really the cream of the crop, and they span across the different GE businesses like aviation, healthcare, which I mentioned that I worked there before during the introduction. And then the development programs are all over the place: commercial leadership, digital technology, the Edison Engineering Development Program. This is the engineering program. You've got your financial management and so forth, all kinds of things. This is really the cream of the cream if you want to work at GE. It's tough to get in, but if you can get in, you've got it made. It's really a great way to get started. So, so that's what I wanted to show you there, and just to be clear about how industry really goes out of their way to support the university. So finally now, so I'm going to wrap up with just this SWOT to strengths, weaknesses, strengths, and opportunities for the system. So like I mentioned before, I've got a lot of good strengths. Courses are great, highly qualified and motivated students. The weaknesses may be poor facilities. You may not have state-of-the-art equipment, but use what you have and use your creativity to make it work for you. Limited availability of internships and apprenticeships. This is really critical. If you're going to make it, you need to start learning, not after you graduate, but during the time that you're still studying at the undergrad level. Insufficient research funding. Government and industry, they need to step up and provide the funds that are needed to support engineering education. And then, of course, there may be scarcity of post-graduation engineering jobs. What are some of the threats? You might lose high caliber students. They might decide to go into law or into political science and become politicians. And that may not be the best thing for our country. And then even worse than that, continued dependence on imported products and technologies. And then finally, what are the opportunities? I say focus on solving local problems. We need a lot of collaboration, like I just said, with industry and government for funded research. And also, I think we really need to provide career counseling, including job placement services, attract companies to come and do on-campus recruiting, and finally, offer courses on entrepreneurship so that when people can't find jobs, they have enough confidence to start their own businesses. So the final takeaway is that it takes theory and practice to make good engineers. So thank you very much.